Hello friends, here we have to obtain the maximum or minimum values of the given function u is equal to s cube y square multiplied by 1 minus x minus y. So you can see here when we open this bracket s cube y square multiplied by 1 minus this x multiplied by s cube y square get s to the power 4 y square. This minus y multiplied by s cube y square, we get minus s cube y cube. For finding maximum or minimum value of function of two variables, first we find partial derivatives of u with respect to the independent variable x and y. So the partial derivative of u with respect to x. This is del u by del x. Here we can see that y square is constant because we have to differentiate here partially with respect to x, and differentiation of s cube is 3x square minus here y square is constant and differentiation of s to the power 4 is 4x cube minus here y cube is constant and differentiation of s cube is 3x square. Now we differentiate 1 partially with respect to y. So s cube is constant here and differentiation of y square is 2y minus s to the power 4 is constant here and differentiation of y square is 2y, and here s cube is constant and differentiation of y cube is 3y square. So you can see that in first step we find partial derivative of u with respect to x and with respect to y. In first step we find partial derivative of u with respect to two independent variables x and y. Now in step second, put del u upon del x equal to 0 and del u upon del y equal to 0. So for maximum or minimum value of u, put del u upon del x equal to 0 and del u upon del y equal to 0. For finding the maximum or minimum value of u, put del u upon del x equal to 0 and del u upon del y equal to 0. For maximum or minimum value, put del u upon del x equal to 0 and del u upon del y equal to 0. You can see here when we put del u upon del x equal to 0, we get here 3x square y square minus 4s cube y square minus 3x square y cube equal to 0. You can see here x square is common and y square is also common. So taking x square y square common here, we get 3 minus 4x minus 3y equal to 0. Suppose that this is the second equation. Now we find put del u upon del y equal to 0. So this 2s cube y minus 2s to the power 4y minus 3s cube y square equal to 0 we get. Here we can see that x cube is common and y is also common. So s cube and y taking common here. So this is 2 minus x minus, you can see here this is 2 minus 2x minus 3y is equal to 0. Suppose that this is 3. So in the second step you can see here we put del u upon del x equal to 0 and get equation second, and put del u upon del y equal to 0 and get equation third. Now solving these two equations, so solving these two equations for from second equation, you can see x equal to 0, y is equal to 0 and 3 minus 4x minus 3y equal to 0. Here when we take x equal to 0 and y equal to 0, the function becomes 0. So x and y both cannot be 0. So we take 3 minus 4x minus 3y equal to 0. Now from third equation, here x not equal to 0 and y also not equal to 0. So we get 2 minus 2x minus 3y is equal to 0. Suppose this is 4 and this is 5. Now solving 4 and 5, we get here. Now solving these two equations 4 and 5. So 4 minus 5, we get 3 minus 2, this is 1 here. Minus 4x plus 2x, this is minus 2x, and 3y is cancelled out. So from here we can see x equal to 1 by 2. Now we find value of y. So put x equal to 1 by 2 in equation 4 or 5, we get value of y. We put value of x equal to 1 by 2 in 4, we get here 3 minus 4 multiplied by 1 by 2 minus 3y is equal to 0. So this is 2 to the 4. So 3 minus 2 equal to 3y. So this is equal to y equal to 1 by 3. So the point is 1 by 2 comma 1 by 3. You can see here in step 1 we find the partial derivative of the given function u with respect to two independent variables x and y. In the second step we put del u upon del x equal to 0 and del u upon del y equal to 0 and get one point 1 by 2 comma 1 by 3. Now we find the second order partial derivatives of u. So first we find here r this is equal to del 2u by del x2, and this can be written as del by del x of del u upon del x. So this is equal to del by del x, and you can see here del u upon del x is 3x square y square minus 4s cube y square minus 3x square y cube. Now we differentiate with respect to x, so 3y square is constant and differentiation of x square is 2x, so this becomes 6xy square. Now 4y square is constant and differentiation of x cube is 3x square, so this is 12x square y square minus here differentiation of x square is 2x, so this is 6xy cube. So this is r. Now we find t is equal to del 2u by del y2, and this can be written as del by del y of del u upon del y, and del by del y of del u upon del y, you can see here 2s cube y minus 2s to the power 4y minus 3s cube y square. Here when we differentiate 2s cube y partially with respect to y, so 2s cube is constant here, and differentiation of y with respect to y, this is 1. Here differentiation of y is also 1, so here 2s to the power 4 minus here differentiation of y square with respect to y is 2y, so this becomes 6s cube y, this is t. Now we find s is equal to del 2u by del x del y, so this becomes del by del x of del by del u by del y. Now this can be written as del u by del y. You can see here this is 2s cube y minus 2s to the power 4y minus 3s cube y square. Now we differentiate this partially with respect to x. So we get here you can see this 2y is constant and differentiation of x cube is 3x square. So this is 6x square y. Here 2y is constant and differentiation of x to the power 4 is 4x cube. So this is 8s cube y. And here we differentiate s cube. So this is 3x square. So this is 9x square y square. So this is s. After that we find values of second order derivative r s t at the point 1 by 2 comma 1 by 3. So at 1 by 2 comma 1 by 3 r is equal to 6x is here 1 by 2 and y square this is 1 by 9 minus 12x square this is 1 by 4 and y square this is 1 by 9 minus 6x is 1 by 2 and y cube this is 1 by 27. Now we solve this. So 2 3 is 6 here and 3 3 is 9. So this becomes 1 by 3 minus here 4 3 is 12 and 3 3 is 9. So this becomes also minus 1 by 3 and here 2 3 is 6 and 3 9 is 27. So this is minus 1 by 9. You can see here. We put in place of x we put 1 by 2 and in place of y we put 1 by 3 and solve this we get r is equal to minus 1 by 9. Now we find t. So in place of s cube we put 1 by 8 minus 2. In place of x we put here x to the power 4 here. So we put here 1 upon 16 minus 6x cube. So here we put 1 by 8 multiplied by y is 1 by 3. We solving this. So 2 4 is 8. So this is 1 by 4 minus 2 8 is 16. So this is 1 by 8 and here 3 2 is 6 and 2 4 is 8. So this is minus 1 by 4. So this becomes, here you can see t is, now you can see here this minus 1 by 4 is cancelled out. So this becomes minus 1 by 8. Now we find value of s. So this is 6 and x square. So x square is 1 by 4, y is 1 by 3 minus 8x cube this is 1 by 8 and y this is 1 by 3 minus 9x square. So this is 1 by 4 and y square this is 1 by 9. Now we solving this. So 3 2 is 6 and 2 2 is 4. So this is 1 by 2. This 8 is cancelled out here 1 by 3 minus this 9 is cancelled out here 1 by 4. Taking LCM here. So this is 12, 2 6 is 12, 3 4 is 12, 4 3 is 12. So 6 minus 7 upon 12, this is minus 1 upon 12. Now we find RT minus S square. So you can see here R is minus 1 by 9 and T is minus 1 by 8 and S square this is minus 1 by 12 square. So minus minus multiply plus and 1 9 multiplied by 8 72. This is, and here we write 144. Minus square is plus, 1 square is 1 and 12 square is 144. So we taking LCM here 144 we get 2 minus 1. So this becomes 1 upon 4. This is greater than 0. You can see here RT minus S square is greater than 0. And r is less than 0 because r is minus 1 by 9. So u is maximum at 1 by 2 comma 1 by 3. So maximum value equal to, we get when we put this point in the given function, so this becomes 1 by 8 and y square, this becomes 1 by 9. 1 minus x is 1 by 2 minus y is 1 by 3. So this is 8 9 just 72, and here we take 1 minus 1 by 2, this is 1 by 2 minus 1 by 3. So this becomes 3 minus 2 upon 6. So this is 1 upon 432. This is the maximum value of the given function. So you can see that when we find the maximum or minimum value of the function of two variables x and y, so first we find first order partial derivatives of u with respect to independent variable x and y. After that, in the second step, we put del u upon del x equal to 0 and del u upon del y is equal to 0 and get some points. After that, we find r, s and t. R is the second order derivative of u partially with respect to x. T is the second order partial derivative of u with respect to y, and s is del 2u by del x del y. Now, in above step, we find some points. At that point, we find the value of r, s and t. After that, we find rt minus s square. If rt minus s square is greater than 0, then we can see r is either less than 0 or greater than 0. If r is less than 0, so the given function is maximum at that point. If r is greater than 0, then the given function is minimum at that point. Then that point put in the given function, we get maximum value or minimum value. Thank you.